Hello everyone. Today we'll be discussing about the project Smart Home System, which has been submitted as our project for project-based learning. So here is the introduction. It's a smart home management system. It's an IoT-based automated toll collection platform that replaces traditional manual. So what is the logic is? So whatever a toll deduction process happening right now is happening at the toll itself. So what we are planning to do is, so vehicle, if the vehicle is behind certain range, suppose like 200 meters away from the toll, then the toll deduction process must happen. So at the time it arrives the toll, the vehicle must move hassle-freely, terminus long queues and toll booths, removes manual verification errors. So here's the tech stack which has been used here. First one is vehicle side. So there are two modules, vehicle side and toll gate side. Vehicle side is just going to send a signal through connectivity technologies. So to implement it practically, we use LoRaWAN, but in this project we have used Bluetooth module. So and toll gate side, we have used the microcontroller ESP32 microcontroller that's gonna receive Bluetooth signal and process the request. So the for the database, we have used cloud database, Firebase Realtime Database. So here's the methodology. So the vehicle module, each vehicle module sends us unique ID signal using the Bluetooth technology to the toll within a range. So the toll module, again with the Bluetooth, receive that signal, sends it to the cloud with the internet connection, that is Wi-Fi, and process it and return the results or the decisions. So, and at the cloud, it's gonna store the vehicle ID and everything and perform the logic. So here's the integration, future integration. We can integrate LCD and add a buzzer and use LoRaWAN for long range communication. So now in this project, we'll be displaying it on serial monitor. So let's move on to the database part. Here is the data part which we were talking. So it's the Firebase, which is a free software which is providing real-time database for us. So here what we have done is we have this URL is there that's linked to the real database. So we are displaying three nodes here with the name vehicles that has a unique ID tag 12345. So that contains certain information like balance, owner, and vehicle number. So this is preloaded for test purpose. At real-time data, if there is something sending the data, that's gonna store in this database and the cloud process would happen. So here we have also included authentication process for signing in. So where we have provided dummy email, which the use of this, which we said later. So here there is real-time database. So this comes in the cloud part. So next, let's move on to the here is the code which we have used Arduino software here. So here we are importing libraries of a Wi-Fi, Bluetooth, and Firebase, which is a very large module that takes time in some uh, minimal computation laptops or minimal power. So here we are defining the password, the API key, and the URL which was there, and the email for authentication. So, and we have defined LED for which the response or the result decision is indicated using the LED. So next one is the Firebase setup. So firstly, we are like providing the pin mode for the LED and writing the LED. Next thing is, so it's gonna print whole starting system and it's gonna begin the process of connecting that is there in the code. Next process is signing in for the Firebase from the email thing. It's gonna sign in. Next thing is waiting for the signal to receive over Bluetooth. After that, the processing happens. Here is the main logic. If the process gets done, it's gonna print successful. Thank you, visit again. If it fails due to some error, it's gonna print as error, and it's gonna receive the Bluetooth module over the vehicle sensor. As you can see, now we are taking a breadboard and one microcontroller that is ESP32, which is suitable for our project, and two LEDs, green and LED, green and red, and now some jumper wires with resistor connected with it. Now we are taking an LED and So there are two pins, longer and shorter. That is, one is anode and one is cathode. You plug it to the breadboard. So what you have to do is the longer side in the same row, you must take jumper wire, that is female to female, and connect it with a resistor. And in the same row where the longer leg is there, connect it with it, and you connect it to D18 or 19 pin, which has been initialized in the code. According to that code only, you must connect. So now I'm doing it in D19. Otherwise, the pins, the data will not be transmitted. So yes, now you must take another jumper wire, that is male to female. So what you must do is you must in the shorter leg in the same row of that thing, you connect it to ground in the ESP32 microcontroller. So the same thing should be done for another LED. So you have to connect in the same manner, but you must the resistor pin will be different. That is as per how we have initialized the code. After this process, we'll move on to the code output. Now the uh, code has been uploaded and connected with the ESP. Now we are gonna see what happens in the serial monitor. So the data is getting exchanged right now. That is connecting with the Firebase, etc., etc. So once it is uploaded, we'll move on to the serial monitor. See, it's uploaded. Now in this serial monitor, as you can see, tool starting the system, tool connecting to Wi-Fi, tool Wi-Fi connected, tool signing into the Firebase, tool Firebase signed in. So through which the this thing is given. So as I shown in the output, which is in the later part, I'm sending a signal. So it is waiting for the tag over Bluetooth. If I send that signal, it's gonna display it has been received. See, the received tag over Bluetooth and the processing tag and thing current balance is that deduction is that new balance is done. So here is the I'm connecting it to ESP. So I'm resetting it from the button. So now it is showing red, that is it has connected to the Wi-Fi, and now it is looking for the signal. So there is a Bluetooth serial terminal app to which devices are there. I'm connecting to from that. If I connect, it is connected as it is shown. I'm sending the signal right now. So if I send that signal, the cloud processing thing happens, and see the detection process takes place. See, now it has turned green. That means the toll deduction process is done, and you can go free.